Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about conditional distribution function. In my previous videos, we have already discussed the concept of conditional probability and concept of distribution function. So now here we are going to discuss about conditional distribution function. So before going to the conditional distribution function, what is conditional probability? The conditional probability of the event A given that event B occurs with P of B not equal to 0. So that is P of A by B is equal P of A intersection B divided by P of B. So this P of A by B is usually read as probability of the event A under the condition that the event B has already occurred. So this one is already discussed in my previous videos. So now here we are going to discuss about conditional distribution function. Let capital X be a random variable. X less than or equal to X is one event and Y is another event. Then the probability P of X less than or equal to X by Y is defined as the conditional distribution function of the random variable X, and it is denoted by capital Fx of X by Y. So mathematically, and it is given by Fx of X by Y is equal P of X less than or equal to X by Y is equal P of X less than or equal to X intersection Y by P of Y. And this is the symbolical representation of the conditional distribution function of the random variable. Okay. Uh, Now here one event is X less than or equal to X is one event and Y is another event. So P of A by B, P of A by B. So using conditional probability, P of A by B is P of A intersection B by P of B. So now here A is X less than or equal to X and B is Y. So this is the mathematical expression, mathematical definition of the conditional probability distribution function of the random variable X. So this numerator term P of X less than or equal to X intersection Y indicates the probability of the joint event X less than or equal to X comma Y. So that is P of X less than or equal to X comma Y. Next, properties of conditional distribution function. In my previous videos, we have already discussed the properties of the distribution function. And what are the properties? First property is fx of minus infinity is equal to 0, fx of plus infinity is equal to 1, and distribution function is numerically bounded between 0 and 1. These are the properties of the distribution function. So now here we are going to discuss about properties of conditional distribution function. And the first property is fx of minus infinity by y is equal to 0. The proof of this property is, we know that from the definition of conditional distribution function, definition of the conditional distribution function, fx of x by y is equal to p of x less than or equal to x by y. So now here x is minus infinity. So using that definition, fx of minus infinity by y is equal p of x less than or equal to minus infinity by y. So we know that using CDF property, fx of minus infinity is 0. So therefore, fx of minus infinity by y is equal to 0. This is the first property proved. And second property is fx of infinity by y is equal to 1. Now coming to the proof, we know that from the definition of the conditional distribution function of the random variable x, fx of infinity by y is p of x less than or equal to infinity by y. From the CDF property, fx of infinity is equal p of x less than or equal to infinity, which is equal to 1. So therefore, fx of infinity by y is equal to 1. And third property, from the first property, fx of minus infinity by y is equal to 0. And second property, fx of infinity by y is equal to 1. So therefore, from the third property, the cumulative distribution function of the random variable is numerically bounded between 0 and 1. That is 0 less than or equal to fx of x by y less than or equal to 1. So the proof of this property is, since the cumulative distribution function of the random variable is numerically bounded between 0 and 1, that is 0 less than or equal to fx of x less than or equal to 1. So similarly, the cumulative distribution function of the conditional distribution function of the random variable is also numerically bounded between 0 and 1. That is 0 less than or equal fx of x by y less than or equal to 1. And fourth property is if x1 less than x2, then fx of x1 by y less than or equal to fx of x2 by y. Next property is if x1 less than x2, p of x1 less than x less than or equal to x2 by y is equal to fx of x2 by y minus fx of x1 by y. So this is the concept of conditional probability distribution function of the random variable and its properties.